Power is essential. Everything we do in our daily lives. Like, we don't even understand how important having a power source is. Energy companies don't want people to build better houses because then they would lose money.
What do you look for in a solar generator?
With solar generators, you have to consider the use case. What is it going to be used for? Do you want something that's really portable? You want something that has enough power to power the devices you're going to need in that situation? Most people think, oh, it's a 100-watt solar panel, I'm going to get 100 watts out of it. That's incorrect thinking.
We got to talk about EMP Intercept Technology, why it's there, why you developed that.
There's a big scare about EMPs right now. The reason that EMPs are so dangerous is that they just fries everything. Ideally, like, there's going to be a nuclear attack, that there's going to be a coronal mass, and that basically makes sure there's nothing else surviving on the electrical grid that can work. It just fries everything.
Why choose a solar generator over a gas generator?
As long as the sun is shining, you've got reliable power when you need it.
Hey guys, welcome to Real Ready Now podcast. I'm Jake Seawolf, your host. Today we have a very awesome guest that I'm glad to introduce to you. We have Rick Evans. He is the man, the nerd behind all of our allies of Grid Doctor. He came out here today to talk to you about electricity and all sorts of sweet stuff. Hey, Rick Evans, why don't you tell us a little bit about your background?
Okay, my background is in product design and engineering. How I kind of got into this solar generator and solar panel industry is I used to work for one of the pioneers in consumer solar generators and solar panels. And that gave me a lot of experience designing product for them. So when I came to this company, they had an opportunity to design some products there, and I went to work on that.
Good deal. That's really cool. And how long have you been designing solar products for?
I'd probably say about 7 or 8 years.
7 or 8 years.
Yeah.
So it's the original.
My background, I've designed all sorts of products. I've done a lot of fitness equipment. I've done a lot of medical products, both diagnostic and medical accessories. I've done stuff in the outdoor gear industry, lots of stuff there. I've done stuff in agriculture, harvesting equipment. So my design engineering experience just ranges a broad range of stuff that I've designed over.
So do you have an engineering degree?
No, my background, this is interesting. My background is actually in industrial design. I found that as I was designing products, that the design intent wouldn't get carried through engineering and manufacturing. So that's why I spent a lot of time engineering and getting to manufacturing my own product designs. So the design was intact. It just kept the whole thing there. And I've been doing this long enough. You know how to design plastic molds, castings, doing weldments, all that stuff. So it just comes with time. But I design it from start to finish the product.
Nice. So you work with like 3D rendering programs or?
Yeah, I use a lot of CAD to get products into a manufacturing form. But before that, there's just a lot of hand sketching, trying to figure out what this product's actually going to look like, what functions are going to be in it, and how to, like, especially with the Grid Doctor lineup, it's how are we going to future-proof this product? Like, I know what needs to be in a solar generator. Let's make that the best and make the functions and the buttons and the display, everything display what a consumer really wants. And then what is the future of that product? What can we put in this product so that it has like a 10-year shelf life before it becomes obsolete? That's especially true with electronics.
That's crazy. Yeah, because electronics, they change and everything's outdated super
That's right.
quick. Why don't we go over kind of what is electricity?
Okay.
Like, I want to break it down super simple. Most people, if you actually ask them like, what is electricity? It powers things. Let's start there.
Okay.
It's a good start.
In its simplest form, electricity is charged particles moving through a conductive material like metal wire. Electricity is the energy that powers everybody's life, from lighting our homes to powering our devices and appliances that we use every day. So basically, electricity is a power source for everything we use.
And then now we've break it down into amps, watts,
Or do you want to go over
watt hours?
Well, there's two forms of electricity that power everything. We've got AC and DC.
AC for alternating.
Maybe we go over that first. That
DC
makes
for
sense.
directing.
Yeah. So there's two different paths. AC power, which everyone's most familiar with. AC is alternating current. And basically, if you can picture a an electron in a wire, it's moving and vibrating. And that movement and vibration causes the electron next to it to vibrate as well. And then the next electron next to that to vibrate as well. So that's what alternating current is. And alternating current is great for the transmission of power over long distances. It's very efficient. And then you get into DC power, which stands for direct current. Direct current is that electron in the wire and it's moving in one direction. You've got multiples of that going in one direction, and that's direct current, and that's great for small electronic devices and stuff like that. So
why is it greater for smaller electronics?
It provides you get into pure sine wave. It gets into I don't know that question, so maybe we should look that one up.
All right, sounds good. Well,
why is it better?
Comments.
I just know AC is better for long transmission.
Does it use less of it or more of it?
It's just different.
So like if you have like two objects, one uses AC, one uses DC, and they both are producing the same amount of output as each other, which one would potentially consume the less amount? Or is that a dumb question?
No, that's a good question. I'm not an expert on this topic, but I would say probably DC is probably more efficient in how it uses power.
And then how is it that like cell phones or small electronics like that, we can charge them from direct current devices or alternating current devices?
Okay, if you have a cell phone that uses DC power, so you can go straight from DC power to DC power, but if you've got AC power like coming into your homes are usually powered with AC power. You have to convert that to DC power, and there's some loss of efficiency in that. But you have to have something called an inverter that changes it from alternating current to direct current.
So is it just like the outlets that we have, they're built-in inverters, or does the phone have the built-in inverter?
Actually, you can buy outlets that have DC power in them. You'll see like a USB plug or something right next to the 3-prong outlet.
Okay, so those have built-in inverters, and that's why they're more expensive.
Yep.
That makes sense. Because like I bought a few of those outlets for my house, and I was like, I can't understand why the price is significantly more.
But also, like when you get a cell phone, it'll come with a USB cable, and it'll come with a little plug. I call that plug a wall wart. You can call it an adapter or whatever you want, but that basically takes the AC power, converts it to DC, and sends it along the USB cable to your phone.
The things we don't think about.
Yeah.
That's happening on a daily basis. Because we have the men behind the scenes that do all this work for us. Watt hours versus watts.
Okay, yeah, there's
watt output.
There's a lot of information here. So basically you've got watts. Watts is the power that is provided. You take amps times volts, and that gives you the watts. Watt hours is more of a battery capacity, how much power is stored in a battery. And then you've got something called amp hours. Amp hours is a little antiquated. It kind of relates back to the old lead acid batteries, and it's hard to compare batteries using amp hours. That's why, especially with all the different chemistries now with batteries and with lithium batteries, you've got nickel, cobalt, iron, magnesium. It's easier to compare watt hours. So that's how that's why when you're looking at solar generators and stuff like that, you want to look at its watt hours, because that allows you to compare apples to apples. And to break it down simply, the math is easier to do with watt hours as well. So let's say you have a 500 watt hour solar generator, and you have an appliance or device that uses 50 watts. To determine how long that battery is going to last, you take the 500 watt hours, divide that by the 50 watts that the device uses, and that gives you 10, and that's 10 hours of usage that the battery can provide power to the device. There are some more calculations in that where efficiency is reduced, but basically it just gives you a rough calculation.
I know we determine that whenever we do like video lights, like on set, how many watt hours we're using versus our watt output. So a lot of that stuff kind of helps us determine how long the set's going to be. If we're outdoors, we're using battery power. But when we go into like the battery types or like amps and volts, I'm not quite educated enough. But as far as watt hours versus watt hour, or watts versus watt hours, the way that it was described to me, that like this is probably the dumbest form to do it, but it's just like, so you have a gallon jug There's your watt hours. And then your watt output, or however big the inverter is that puts out the electricity, is going to be determine the size of the opening of the jug. So essentially, like, you can dump that out either faster or slower depending on the inverter size.
Yeah, a lot of people relate amps and volts and watts to like home plumbing. So if you think about it, think about a pipe in your home with water in it. And the flow of water through the pipe, that's your amperage. The force of the water and the pressure of the water in that pipe, that's the voltage. Nice. And then the outcome is the watts, because you take amps times volts and that gives you the wattage. So that's another way to think about it.
So on our Grid Doctor lineup, do we tell the amp hours or anything, or the volts?
We don't mention anything about the amp hours. We do have a voltage, and it's different. So on the AC outlets, it's 120 volts, because that's the standard we use in the US is 120 volts. And we do have an inverter on the Grid Doctor. Our Grid Doctor 3300 right now has a 3300, coincidentally, has a 3300 watt inverter. So it takes the DC power from the batteries and it puts out 3,300 watts of power. Did that make sense? I hope so.
I mean, it makes sense to me. Just hope it makes sense to the listeners. So if you guys do have questions, ask in this comment section, or comment how handsome Rick is, whatever. Now let's kind of go over a little bit more of battery types. And I almost want to start like historically, like what was the very first battery type? And it boils down to, we went with LiFePO₄ and why and what that is.
As far as battery types, when I was first doing battery setups with solar panels, we were using lead acid batteries. The problem with lead acid batteries is that they're very heavy and there's some maintenance involved in them. Years ago, things started switching over to lithium batteries. Lithium was great. It was super lightweight, but it had a problem. It was dangerous. And you've seen a lot of YouTube videos where people are puncturing lithium battery packs and they explode and flames come out and stuff like that. Since then, there's been a couple new chemistries coming out. With the advent of electric vehicles and stuff, there's a lot more battery tech out there. So there's three different primary batteries that are out there. There's lithium iron phosphate, there's nickel magnesium cobalt, and there's lithium cobalt oxide. The latter two are used a lot in electric vehicles because they can provide a lot of power. The problem with those batteries is that they use cobalt and nickel, which are horrendous for the environment as far as refining and stuff like that. A lot of that is done in Africa. And the advantage to them is that they're lighter. And then let's go back to the first one, lithium iron phosphate. That's the battery type that we use in our Grid Doctor lineup. And that's the one that most people use in a lot of these solar generators. And they use them in some of the Tesla models as well. And the main advantage to lithium iron phosphate is that it's safe. It uses iron, which is a very stable product. It doesn't want to catch on fire or anything like that. So using iron as the cathode in the battery makes a huge difference for safety. The only disadvantage is that lithium the lithium iron phosphate weighs a little bit more for how much power you get out of it. But other than that, it's a great, another advantage of lithium iron phosphate is that it's cycle time. Cycle time is basically being able to charge the battery up fully and then discharge it fully. And lithium iron phosphate, there's different versions of it, but they can go from 2,000 to 5,000 cycles. So if you think about that, if you can get 5,000 cycles out of a lithium iron phosphate battery, that's gonna last you over, if you do a full cycle every day, that's over 13 years. So that battery is gonna last a long time. Some of these others, like LCO and NMC batteries, those will cycle like 1 to 2,000 cycles. And you've got the old lithium battery tech, and that was about 500 cycles. Lithium iron phosphate is the way to go right now as far as safety and cycle time.
In terms of like the revolution of battery power, clearly you're the most pro for the LiFePO₄. Is that segmented lithium iron phosphate?
Yeah.
Now, in terms of, you say it's safer for the environment. So, and it lasts, would you say it lasts longer than the cobalt or the nickel ones?
Yeah, it does.
And what was the disadvantage of it? Is it just because it's a little bit heavier? That's it?
Just heavier.
And not even by a grand scale, like just
I don't know the exact numbers off the top of my head, but
a rough percentage?
Yeah, it's probably about 20-30% heavier or dense. So you'd have to have, if you took the same size of space and put a battery in it, the lithium iron battery would be about 20 to 30% bigger than one of these other types.
But you're gonna have a longer lasting battery. You're
And
gonna have a safer battery.
Safer is key. There's a lot of stuff in the news. You see all those kids' toys coming out of China where they're blowing up because they're using a kind of lithium battery that's not managed correctly and stuff like that.
That's crazy.
But that gets into the battery management system.
I had no idea anything about that.
There's a fire. There was a house that caught on fire in my neighborhood, and it was all from one of those electric scooters that just the battery just poof, and it caught the whole house on fire.
That's insane.
So you got to have safe batteries.
So LiFePO₄ is the way to go.
That's right.
It's a grid doctor for you. Okay, we're gonna go over the basics of solar. Now, to my understanding, there's two different types of solar panels, at least like the crystals that collect the energy from the sun.
Yeah.
I don't know. Let's go in a little bit about that.
Okay, so you won't see these a lot, but there's two types of solar panels. There's polycrystalline and monocrystalline. I should have brought in some samples of the wafers so it makes sense a little bit more. But polycrystalline are just faceted silicone cells put together to generate electricity. They're not as efficient as monocrystalline, which is a solid cell. And the solid cell is basically like you can get them in different sizes. You can all the way up to like 6 by 6 inches squared. And it's just a super thin wafer of silicone. So polycrystalline solar panels are kind of, I think they're on the way out. They're cheap, but they're just not efficient for the amount of space you have. Monocrystalline right now is the big player in the field. There's emerging technologies. There's bifacial solar panels, which absorb sunlight from both sides. Yeah, so a lot of people put those on gazebos or outdoor awnings and stuff like that, or use them as fences because it can collect power from sunlight from both sides. So basically, the construction of a solar panel, I've been to China many times, been to these solar factories. Basically, you get these rectangular silicone wafers. They've got like a blue and black iridescent look to them. They're pretty cool. And they lay those out in a certain pattern, and they run metal leads or wires over them. And so what happens is the silicone, there's a positive layer on top and a negative layer on bottom. And when sunlight hits the silicone, it kicks off an electron to one of those layers, and it goes in one direction because there's an electromagnetic field created from the positive and negative. And that creates a direct current or DC power. And that DC power is shot through the wires back to the solar generator to power up the battery. That's basically simple explanation of how a solar panel works.
That's wild.
Yeah, you've got the silicone wafer, you've got a positive and negative layer, and when sunlight hits that silicone wafer, it kicks off an electron. That electron shoots through the wire and charges the battery.
So when you get into like higher wattage solar panels versus lower watt, is it just because the panels
are bigger,
have more cells?
Yeah,
essentially.
Just have more cells.
And then you talked about the what was the one?
Bifacial.
Bifacial.
So bifacial absorbs the sunlight from both sides and generates electricity that way.
So are they putting those, so like even if you just have them laid out like a regular solar panel, is it still collecting from both sides?
Yeah.
And why would we?
Oh, so the bifacial have to have metal leads on both sides of the panel to collect it, whereas
I assume it's more
the traditional, it is more expensive. The traditional, more monocrystalline panel has the electrical leads on one side of the silicone wafer.
So when for grid doctor solar panels did we go with monocrystalline instead of bifacial?
It's just a great value. It's affordable. It's just a great value for what you get.
Does it make it more lightweight as well, or
no? So there's different ways of constructing these solar panels. you've got, most people are familiar with the ones that people see on top of houses. Those are glass panels with usually an aluminum frame around them. And those are used across the industry for home solar. And those are more permanent solutions for installing solar. The ones we offer are more to pull out during an emergency. They're lighter weight because they don't have the glass on them. We use a resin on top of the solar panel to protect it, and we laminate it. We used to have some cloth ones that carried that was the frame for the solar panels, but now we're using a full lamination, which is a little more durable and
waterproof.
Yeah, and they fold out. You can store them away easily, and that's what we went with. So
Well, not just for emergencies either. I mean, take that stuff camping all the time.
you can take it's just
anywhere.
great for camping, more mobile is what it is. Where the glass ones, the tempered glass ones, are more of a permanent solution. So if you're trying to power up a shed, a cabin, or something like that, you'd want to use probably the tempered glass with the aluminum frame panels. Where if you're just pulling it out in an emergency situation, or while you're building a cabin and you're carrying the stuff in your truck, you pull out those panels, set them up, and power up your generator. So there's lots of different use cases.
Rick, now we've got our Grid Doctor lineup here. Pretty much the big person while you're here to explain to us everything. The Grid Doctor 65 watt power bank. I use this thing everywhere. It's lightweight, portable. Why did you develop this? What was the inspiration?
Okay, I love the 65 watt power bank. Basically right now, currently on the market, most of the battery packs are designed for charging your phone or your tablet. And those only require about 15 watts of power. And I wanted a power bank that would do a little bit more than that. And I kind of saw where the industry was going with more powerful power banks. So it's like, we need to be on top of this. So I worked with the manufacturer. We were able to get 65 watts of power using the battery cells inside this.
What do you mean by 65 watts of power?
So 65 watts of power, it's just more power out. So the max on most power banks is about 15 to 18 watts of power out is the max, even in fast charging mode. This can deliver 65 watts of power out. So what that means is you can power more devices at the same time, or power a single device that requires more power.
Like a laptop.
Yeah, so this one will actually power the majority of laptops out there. There's some gaming systems and stuff out there that require a lot more wattage. But for most of your laptops, your business laptops, this will take care of it. I also incorporated, just for convenience, we have a built-in USB-C cable, and we've got a USB-C port here and a USB-A port. I also put a light on it. The light has 3 modes.
Turn it on. Let's see it.
Yeah.
Light bar.
It's a
It's
double
a lifesaver.
Yeah, it's a double press to turn it on. And then you've got bright mode, low mode, SOS, and then off. And then if you just do a single press on the button, we've got a battery indicator that shows you the level of battery. I also put a really robust anodized aluminum clip holder here. This is just for convenience for putting like a carabiner in, or tying it down, or putting it somewhere or holding it. So yeah, so this is a great product. I love it. Oh, just a little side note on this. So most battery packs, they use, if you're familiar with like a AA, it's a cylinder, metal cylinder with sleeve, and it's got little cells in it. The lithium batteries are constructed very similar. In that it looks like a cylindrical cell, and most of the battery packs out there are using 18650s. That's the size of the battery, and those are small and they keep it thin. But because we needed more power and stuff, we went up to a 2700, and that allows just more power and more density. But this is a very safe battery pack. The battery inside this is encased in steel. So a lot of the issues that happen with battery packs is you'll see them, they'll kind of expand and explode. It's because you're using foil packs inside to hold the battery chemistry, but we're using steel jacketed cases to hold it, so we won't have that issue.
So we went all out on that.
Yeah, this is very, very safe, very reliable, very robust. This will power basically most of the stuff you're gonna ever need.
I mean, I've been using traveling, flying, everything.
Yeah. Oh, airplane safe. On the bottom here, I put a little graphic so TSA agents can easily identify this, as this is safe to fly with. But it's only safe to fly with a carry-on.
Which luckily I had in my carry-on.
Yeah.
But also the 65 watts, I mean, it recharges my phone super fast. So if I've got 3 people lined up wanting to use it, I mean, 30 minutes, I can pass it on to the next person. And I almost have a full charge.
Okay. Oh, just another thing, like there's a little confusion on this, and maybe we can clear this up. To charge this, the best way to charge this is if you have one of our bigger Grid Doctor systems and use the USB-C cable to plug in to the battery.
Is that for the power delivery port?
Yeah, the power delivery port. If you're going to use one of your phone chargers at home to charge this, it's going to take all day, a long time, unless you can get a 60 or 65 watt wall charger, or wall wart as I call them, and that will charge this up in about an hour and a half. So that's the best way to charge this. You can do fast charging on it, but you have to have the right adapter and stuff to do that.
Now, would you recommend just using the onboard USB-C cable, or are you using the ports?
You can use either. You want to use the USB-C cable. Both the USB-C cables are input and output. The USB-A on this is only output.
So pretty much just USB-C only.
Yeah. And if you're using another thing, this is the 65 watt, but this has a max of 95 watts of output if you're using all 3 ports. 95 watts.
That's still pretty good.
Yeah.
All right. Let's move on to the little solar panel that you can get with it.
Oh, yeah. Okay. This is a great little product. This is a 15 watt solar panel. So I designed a solar panel that would work with the Grid Doctor 65 watt battery pack. And this allows people to be out on the go. This is more for camping, for hiking, for just being out away from civilization where there's an outlet. This will allow you to recharge your battery bank. Some of the conveniences are, let me open this up real quick. So this is what it looks like displayed. You can hang, there's some little holes here, hanging tabs where you can hang it from your backpack or whatever, or hang it on the side of your tent or camper or whatever, just to collect the sun's rays and charge your battery. Inside here, got the instructions. But one of the things I did is I included an attachment cable, a USB-C attachment cable, a male attachment, and then I also included a female USB-C attachment. So basically, you can plug in the cable from here into the transfer box on the solar panel, zip it all up, and hang it in the sun, and it'll charge up completely. So it's all in one package.
This kind of brings me back to some of the solar panel stuff. So the cool thing about this is, like, I mean, it's really flexible, but how does that affect, is this still monocrystalline cells?
Yeah, these are monocrystalline cells.
How is it flexible like that and it looks different?
If you look very carefully, you can kind of see the cells going across. They have to cut these in the factory and then they just lay them out. So each one of these panels is about 5 watts. We've got 3 of them. So
it's pretty cool.
Really cool product.
Snaps together.
Yeah, snaps together. Just convenient, holds the battery inside the pouch. You can also store other accessory cables or whatever you need inside here. But no, really good product.
Put a bag of Swedish fish in there, let it melt a little bit.
Exactly.
Now, this one's been out for a minute. The Grid Doctor 300. Why did you make that? And what was your intent for it? What was the purpose?
With solar generators, you have to consider the use case. What is it going to be used for? Do you want something that's really portable? Do you want something that has enough power to power the devices you're going to need in that situation? And basically it breaks down to, you want something that's very compact and portable, like the 65 watt you can throw in a backpack, but then you want a little more power. Say you're going camping, or you want something in the car, or you're going to experience a blackout and you want to be able to power up your phone and some small devices. That's where the Grid Doctor 300 comes into play. The Grid Doctor 300, so basically how we've labeled these, so when we say the Grid Doctor 65, that means it provides 65 watts of power. When we have the Grid Doctor 300, that means it provides 300 watts of power. And when we've got the larger home system, which is the Grid Doctor 3300, that's 3,300 watts of power. So this delivers 300 watts of power. It's got a watt hour, which is different That's 320 watt hours. So with the Grid Doctor 300, this will accommodate laptops, cell phones, lights. Lights are super important during blackouts and during camping. And basically most of your devices, like if you're going camping, a lot of inflatable mattresses will need a power source. So this is perfect for camping and for really short duration blackouts. We've included AC ports for some of the larger appliances. We've got the DC USB ports. We've got 2 USB-A high speed 3.0. We've got 2 USB-C PD ports, PD meaning power delivery. We've got a 30 watt out and a 65 watt in and out.
So in and out. So now you're talking, you can charge this device through the power delivery port.
Exactly.
As well as charging other devices.
Correct. We've got the 12 volt DC ports. These are more of a legacy port for some older electronic devices that may need those. We're using the same barrel connector for the input from the solar panel. And then we've all got the car port. Everyone's familiar with this. This is kind of antiquated and old too, but a lot of devices still use that. And one of the things that you'll notice on a lot of solar generators is we've got little power buttons over each of these, because if you turn this on and all the ports are active, it's wasting power.
Now it's trying to send juice to the ports.
It's trying to send juice to those ports and be ready to send juice to those ports. And it's going to drain the battery. So that's why you turn it on. And then if you want to activate certain ports, you press the power for that port and it'll turn it on and make it active. But you want to turn it off when you're not using, otherwise it's just going to drain the battery.
Now, on the flip side of that, you can technically use all ports at once.
Yes, you can use all ports at once. One thing I like about this is it's got a flat top, so you can stack lots of stuff on it. A lot of people, I know those people who work remotely, you see them living out of their RV or their tent, and they're working on a laptop. This is perfect as a laptop stand. You set it on there, plug in your laptop, and you type away and do your job. We got an easy, convenient carry handle. This thing weighs probably about 10 pounds or something like that.
It is light.
Super light. We've got a light on the back that goes through all the different modes. Now we can turn on the light. But yeah, the light goes through the different modes. It's got high beam, low, SOS, and strobe. Great product. It's got cooling vents on the side to keep the battery cooled while it's charging.
And this, I assume, LiFePO₄ battery as well?
Yeah. This uses the lithium iron phosphate battery. Very safe, very stable. You'll get anywhere from 2,000 to 5,000 full cycles on this. So this will last you a long time.
And then it comes with the 100 watt solar panel.
Yep, this comes with the 100 watt solar panel. Oh, let me explain some of this. This is kind of cool. So we offer a 100 watt solar panel with this. The max power that can be input into this is 80 watts. But let's go through some scenarios. So say you've got your 100 watt solar panel out in the sun. Most people think, oh, it's a 100 watt solar panel, I'm going to get 100 watts out of it. That's incorrect thinking. You've got to reduce the power probably like anywhere from 80 to 50% of the solar panel rating, because the solar panel is tested in a laboratory, and that's the maximum, that it's in perfect conditions, and that's what it will achieve in perfect conditions. But most people, it depends on where you live in the country even.
Like the angle of the sun versus
the angle of the sun. People back east, they experience a lot more clouds. So you're going to have clouds drifting over, which doesn't allow your solar panel to receive as much sunlight. And you've got to think also during the day, most people get about 5 to 7 hours of sunlight that's usable for a solar panel. And to optimize a solar panel, you have to have it perfect, perpendicular to the sun. And most people a lot of the solar panels come with kickstands, and you can adjust them to try and maximize that perfect angle. But the sun's always moving and the earth is always moving. So you've got to slightly, over time, adjust it throughout the day to get that perfect setting. So in situations where you're not going to be getting the perfect sun conditions, that's why we say you can plug in up to 2 solar panels on this. So that would be a scenario where you've got a partly cloudy day. Your 100 watt solar panels probably only achieving 40 watt max of power. So that's why you plug in 2, you get 80 watts going into this, and basically allows you to charge your battery back up as fast as possible. Sometimes you'll be able to get away with 1 panel, but when the weather's not great, even in the winter, plug in 2 panels. It'll charge up your battery a lot faster.
Or if you're not at a campsite, you can plug panels in facing various angles.
Yeah, that's another
Reflecting
situation.
the sun as it goes across the sky.
You angle a panel for the morning sun, and then you angle another panel in the afternoon sun, and then you don't have to touch them. So there's a lot of situations where having 2 panels to charge this up will make a huge difference.
For sure. This sweet little device. It's so lightweight too.
We're trying to make it as easy as possible for consumers to...
People who don't go to the gym can lift it.
Yeah, use it. Yeah, exactly.
Perfect. Well, thanks, Rick. It's a pretty awesome little battery. Now, Rick, we've got the big, what do you call that? The 3300.
The 3300.
The Grid Doctor 3300.
Yep.
This is the masterful, the beautiful, the thing that's going to power everything that I need, at least. Maybe not quite a full-size home air conditioning use it, but I hear electricians connect 2 of them together.
You would need an air conditioner and a furnace are some of the largest energy hogs in the home. There are special things you can do for air conditioning and furnaces, but I would not use solar generator for those.
Good to know. Now, with that being said, let's talk about the Grid Doctor 3300.
Okay.
Why did you develop this? We recently updated it for EMP protection. We definitely need to know about that. Has a ton of freaking ports on it. It can just so many wires that you can plug into this thing. Why did you make it?
Okay, let's get into it. First off, we started out our large unit. We made it a 2200 watt output, and we offered that to the consumer. It did really well, very successful in the marketplace. But we were getting some feedback that consumers wanted to power more things with it, and we answered the call. So we upped the inverter inside the Grid Doctor 33, the current Grid Doctor 3300, to 3300 watts of output. That will handle refrigerators, microwaves, power tools. I use mine all the time in the garage. I have mine on a little roller. I use it for welding. I use it for my table saw.
What size of welder?
I just got a 120 MIG welder. It's great. Delivers the power. The 3300 has an RV port on the side, a 30 amp, and I just plug in my welder to that. It does phenomenal. It's better than my home electricity because my home always throws a breaker.
Nice.
So I love using the Grid Doctor home. So basically, yeah, we upped it to 3300 watts of power going out, and then just recently we added EMP protection. This thing is phenomenal. Basically, think of it as a surge protector and circuit breaker on steroids. And we can get more into the details of how EMP works.
Which we are going to get more in the details. That's
the
why we're here.
Technicals of that and why people need this kind of protection. But the 3300 is a great unit. You've got 4 AC ports that deliver 20 amps. We've got an RV port on the side, which delivers 30 amps. We've got 2 USB-A, 2 USB-C, and 2 USB-C PD power delivery ports. As far as the DC, we've got this the car port, or also known as the cigarette lighter port. Very common in a lot of these things. We've got the barrel ports, the DC 5521. And also we've got the, the aviation port. This is used in a lot of radio communication setup and stuff like that to power those devices.
Like what, a ham radio?
Yeah, ham radio, for instance. Perfect. Yeah. So those are the main ports we have on. We also offer the input. This is important. So one of the big things with the 3300 is I wanted fast charging. Fast charging mean I want to be able to charge up the Grid Doctor to full capacity in as short a time as possible. So right now, you can charge up the Grid Doctor 3300 just a little over an hour, full capacity.
From
0 to full capacity in a little over an hour. It can take 1600 watts of power on fast charging. So let me back up there. So we do have a normal charge, and then we have a fast charge coming in from an AC port from your wall. Depending on how much your home can deliver in power, you can power this thing up pretty quickly. And that's especially useful when you've bought the expansion packs for the 3300, because those allow you to span how much power you have and how much energy you store.
So real quick so you have a fast charge and a slow charge.
Yes.
And you can flip the flip of a switch, decide how you're going to do that.
Yep.
Why would you not just leave it on fast charge all the time?
It depends on your home electricity or where you're getting the power from. It may not be able to handle that. So if you got a room in your home and you're using a lot of power already in that room and you click on the fast charge, it's going to throw the breaker because you're exceeding the circuit in your home and it's going to not allow that power to go through. So it just depends on the power situation. If you've got a room and nothing else is being powered in that room or on that circuit breaker in your home, it can easily handle the full 1600 watts.
And if you have it on fast charge all the time, does that destroy the cycle life or anything like that?
Yes, but not enough to really notice it. So anytime with any electronic devices, fast charging is not as good for the battery, but it's really not enough to notice.
But if you're getting 5,000 cycles out of it, is that going to subtract it by X percentage, or like really just not even?
It's not really noticeable. Oh, the other thing is, one of the things we recommend with these is we recommend plugging these in. So if you're storing these in your house, just plug it into your AC outlet, keep it on the regular charge speed, and if it starts going, so that if it's always plugged in and the power goes out, you're always going to have a full capacity. If you're going to do something like a long-term storage, like, for a year and a half, you're not going to use this thing, the best way to store these batteries is probably around more of the 50% range. So you want to unplug it, discharge it a little bit down to around 50% and just let it sit. That's the ideal capacity for a battery for long-term storage. But as far as keeping this at home, keep it plugged in, keep it fully charged. When the power goes out, you've got power when you need it. You can run your refrigerators, you can cook your meals in a microwave, you can power your phones, you can have the lights on. This thing's really a power horse. It's expandable.
And I noticed that, like, with the expandable option, you have it set up so it just stacks. Super convenient. Yeah. Why did you make the cables the way they are, though, where they just stick out on the sides?
We wanted something, so this stacks. We have this set up so you can add 7 additional expansion batteries. So we're calling this the head unit. The head unit has 2,048 watt hours. Every expansion pack also has 2,048 watt hours. So you can go from 2,048 watt hours, adding 7 more expansion packs and get over 16,000. I thought it was more like 16 something.
Well, it's 2,048 times 8 because you're including the head unit plus the 7 more.
Yeah. So I can't do math in my head.
I know we advertise it a little over 18,000.
Okay.
Oh, we haven't? What is the number?
Yeah.
So a
little over 16,000.
16,384.
Yeah. Of watt hours. And that's enough power to basically provide power for your home if you're using all your accessories in a blackout for a day. But here's the thing, in an emergency situation where there's no power, the things you want, your phones to work, you want lights to work, and you probably want to run the microwave for a little bit.
And the refrigerator.
And the refrigerator, so your food doesn't spoil. And those are the main things. This is not a great thing for powering your AC. The AC is an energy hog. You can do it, but I would see, if you're in an emergency situation, I would run some fans or a little window unit AC if it's really that hot out there. It draws so much power. It's crazy. They're like, seriously, 40% of all homes consume, or 40% of someone's electric bill is all heating and cool.
Mine's worse because I keep my house at 70 degrees.
Oh, yeah.
In Utah.
So if someone could actually develop more efficient heating and cooling for our homes and buildings, that's a game changer.
Seriously.
For power consumption.
Well, over in Dubai, they had like the big umbrella things that expand over the windows. during the day. They've been putting them on the big buildings. They said like that's been drawn out like 40% less, or how do you say that? They've been 40% more efficient just by doing that.
Yeah.
And like they're not even like fully blocking out the sun. It's like just a mesh that kind of comes over.
I think as far as homes go,
kind of block it.
If home standards were better, we would save so much on electricity and our energy.
With insulation too, and just
completely. Yeah, but it's all a game. It's all a game. Energy companies don't want people to build better houses because then they would lose money.
The big unit, we have the 200 watt solar panels.
Yeah. Okay. So on our 3300, we've paired it up with some portable 200 watt solar panels. The input, the 3300, is 1,000 watts. So you can match 5 solar panels. So just think of it. 200 times 5 is 1,000. This will take 1,000 watts of solar panels. In fact, you could probably plug in 6 solar panels set up because you know you're not going to get a full 200 watts out of each panel. But yeah, this is great for fast charging. If you're plugging in 4 or 5 panels to this, you can charge this system pretty quickly.
And to top it all off, you've built us an extension cord so you don't have to pack it all outside.
That's right. So right now the solar panels come, I think it's about a 15-foot cable. That's good for most situations, but we did develop, and this is really unique, we did develop a 75-foot extension cable. Part of that 75 feet, 15 feet of it, we actually worked with the manufacturer and was able to develop a really thin cable. And the thin cable allows you that last 15 feet to put that power cable underneath a window sash or underneath a door and still close it. So we made some really cool improvements on that extension cable.
Keep it weather locked up.
And it allows you to keep your door and windows shut, and you can have those solar panels stretching out to the ideal situation where in the yard or wherever you're setting them up, and then keep the solar generator inside, protected away from the sun and the heat and the elements.
That is really cool. Now, the nice thing about, so every Good Doctor product has a pass-through ability. That's what we say. The terminology pass-through.
Yep.
What does that mean?
Okay, pass-through, there's 2 things we want to talk about here. There's pass-through technology, which allows you to charge the battery while charging other devices from the battery. That's pass-through technology. And we incorporate pass-through technology on our Grid Doctor 65 watt and our Grid Doctor 300. Those both have pass-through technology, meaning you can charge the battery and charge appliances at the same time. The Grid Doctor 3300 is a little different. It does have pass-through technology, but it's got something even better. It's got UPS on it, which is uninterrupted power supply. Years ago, I remember like most of the time people had UPS systems set up on their work computers, or on their home computers. So when the power goes out, the UPS system in milliseconds switches over to using the battery. Basically, we've incorporated that UPS technology into our solar generator. So basically, you can have the solar generator plugged into the wall, and then you can have your computer or other appliance plugged into the solar generator. And if there's any power surge, any interruption of power, blackouts, whatever, Grid Doctor will switch over in nanoseconds, and your computer, whatever, won't even know the difference. So so you won't lose your data, your paper you've been typing up all day, or any work you've done.
Or if it's medical device plugged in.
Or a medical device. Yeah, it's great. It doesn't have to reboot or anything. It just treats it like there's no interruption in power.
That's pretty cool.
Yeah.
EMP, we got to talk about EMP Intercept Technology, why it's there, why you develop that. What if I don't care about EMPs or don't even think it's real?
EMP, the EMP protection we provide, we call it EMP Intercept Technology. And it focuses on several different dangers that might affect people. Lightning strikes. Everyone experiences lightning strikes. That causes a surge in the power lines.
How does a lightning strike cause a surge in power line?
It either contacts the power line and energizes it and sends the voltage spike through power lines into your home. And if your home doesn't have any kind of protection, it's going to fry all the appliances in your home. If a lightning strike hits your home, it's going to be direct, go right into your power and blow out all your stuff. So it's great for lightning strikes. The other things it's good at that are not talked about too often are coronal mass ejections and solar flares. Let's go over coronal mass ejections first. Coronal mass ejections are basically volcanoes on the sun ejecting plasma out into space. And that plasma takes a while to reach the Earth, but it will affect the electromagnetism of the Earth and cause fluctuations in power through the power grids on our planet. And that will affect electronics too. So this protects.
How often does that happen?
Probably more than we think, but usually we'll have some heads up or warning from NOAA or some other government agency, NASA. Solar flares are just energy disturbances that radiate off the sun. These also can transmit power to the Earth, which affects the electromagnetism of the Earth. And then we've got an EMP. EMP, I know it's been in the news a lot lately. The biggest fear, the biggest source of those is nuclear weapons. Nuclear weapons cause an EMP, and we can get into more details on some of the effects of an EMP, but there's 3 phases in an EMP. But let me back up to some of the protection that the Grid Doctor allows. So there's something called a circuit breaker. Everyone's familiar with a circuit breaker. They're in your homes. You go into your basement, wherever your electrical panel is, open up that gray box, and you see all those switches. Those are circuit breakers. And they're usually labeled like 15 amp, 20 amp, 30, 50 amp, whatever. And when the power goes out or you blow a circuit in your home, you go down, you flip it off, and then flip it back on, and power is restored. That's a circuit breaker. Circuit breakers protect against amperage, so surges in amperage. And then the other thing we incorporate into the Grid Doctor protection is basically a surge protector on steroids. Surge protectors protect against voltage surges. Voltage surges are caused from lightning strikes. They're caused from coronal mass ejections, and they're caused from EMPs. Amperage spikes are caused from solar flares and EMPs. So there's a mix. The reason that EMPs are so dangerous is that they cause a surge in both amperage and voltage. And that just fries everything. So we've incorporated just heavy duty hardware into the Grid Doctor 3300 to handle the surges from both voltage and amperage. And the trick with EMPs, the reaction time of an EMP is super fast, like in the billionth of a second. So the equipment we've put in there reacts in less than 3 nanoseconds, which is 3 billionth of a second. So it reacts super fast, which is important for EMP protection.
You said 3 billionth of a nanosecond.
3 billionth of a second, which is 3
measure
nanoseconds. Special equipment.
Yeah, it'd have to be special.
Yeah,
because that is moving.
So basically, with the electronics we've built into this, it's already built in, so you don't have to buy any other accessories to protect yourself against this stuff. So ideally, if you know that there's going to be a situation, like there's going to be a nuclear attack, that there's going to be a coronal mass ejection or a solar flare, you're probably given a little heads up on that. The best thing to do is unplug this from the grid or your wall and just let it sit, and it should be fine. Lightning strikes are a different story. You never know. You're not going to go around and unplug all the devices in your home when there's a storm coming. So that's why this protection can even protect against lightning strikes and stop it from damaging the internal electronics. It just shuts it off right there.
When it does hit it, does it shut off the unit itself to protect itself?
If the unit's on, it will shut that off, but it basically just pulls the plug and won't allow it to connect to the other electronics.
Or then you just got to return it back on? Or...
Yep, just turn it back on.
That is really cool.
And we also offer a Faraday bag with the Grid Doctor lineup, and I'm always saying the more protection, the better. And a Faraday bag or a Faraday cage operates a little differently. So let's say with an EMP, the radiation, the electromagnetic wave that hits the Faraday bag, which is basically a metal mesh encasing the product, the energy hits that and it wraps around it, but it won't enter it. That's why if you have a Faraday bag, you have to have it completely sealed. So you can't put this in a Faraday bag and have this plugged into the wall at the same time. So there's a little difference there, but the more protection, the better.
Is that kind of why we make our Faraday bags waterproof as well?
Yep. And it's a great place to store extra cables and whatever. So it's just a great accessory. And then just to get a dive a little bit more into EMPs. So there's a big scare about EMPs right now. EMPs happen very fast. There's 3 phases to an EMP. There's phase 1, phase 2, and phase 3. The first phase of an EMP happens in nanoseconds. It is so fast. It goes, and it depends on how close you are to the nuclear detonation. Because if you're too close, you're not even going to survive. But if you're far enough away that you survive, but you're still impacted by the electromagnetic wave that's created and the gamma radiation. So basically, the wave hits our electrical grid, and it transfers power through that. That's another way that EMP can affect electronic devices, but it all happens super fast, and it overpowers everything in the electrical system because it's so fast that nothing has time to break the circuit or prevent the surge. You've got the first phase, which basically decimates all electronics. The second phase happens in the same amount of nanoseconds, super fast, and it's almost like another sledgehammer coming, and it just makes sure that all the electronics are out. And then the third phase can last anywhere from a second to minutes, and that basically makes sure there's nothing else surviving on the electrical grid that can work. It just fries everything.
And this all happens within a minute.
So the first 2 phases are in nanoseconds. The last phase lasts from seconds to minutes.
So 1 through 3 is basically guaranteed going to happen with a nuclear detonation.
It's going to take out everything.
Because I've always read phase 1, phase 2 is like different things completely.
Yeah.
I didn't know
Well,
that. It was like a buildup as one singular.
It's a combination of electromagnetism and radiation.
Makes sense.
Hitting all these electrical stuff, and it travels. So electricity can travel through any metal conduit. So that can be your pipes. If your pipes are metal, it can travel through transmission lines, all sorts of stuff.
That is insane. Where would you say you're safe from an EMP attack from a nuclear detonation? It probably depends on the size.
Where you're safe?
Yeah, never.
Oh,
but like,
I'm not sure. Like, I know gamma radiation is not going to be good for you. So.
If a nuclear attack happens, right? Obviously, everything within X amount of wave
radius is going to be killed.
Yeah, you're dead no matter what.
Yeah.
But then you have like an outer phase. Like, how much further would an EMP?
The radiation fallout?
No, just the EMP part. Like, is it possible to be like not be in a kill zone of a nuclear detonation, but also still be in the zone of like?
I don't know. Actually, that's something that's interesting. I'd like to see how far an EMP can be carried, because if our transmission lines carry it, it could literally a bomb could go off on the East Coast. The surge in power, if we've got our electrical system,
take out that entire grid.
Yeah, it could take out a whole grid and surge everything. There's some danger to that. I bet you it could take out the whole country.
That'd be wild.
Yeah.
Hopefully we never have to see that day.
Nope.
But in the meantime, I mean, you're still protected.
Yeah, you're protected because everyone experiences lightning strikes. And here's the other thing.
Or just typical power surges.
It's just not lightning. Power surges are caused by lots of different things. So say the power goes out and the electrical company switches the power back on. There's going to be a slight surge. If you've ever noticed in your house and the lights start dimming and then going bright and dimming, that's another fluctuation in the power. And that's going to do havoc on your electrical systems. So having one of these is going to, if you're running this as a UPS or a pass-through, you're going to protect your electrical devices in your home.
Which is really cool. Just make sure you buy the whole kit, everything that comes with it, Faraday bag, extension cord. Tell us, Rick, what do you look for in a solar generator?
When you're looking to purchase a solar generator and solar panel, the first thing you want to look for is the watt hours. So that's basically how much power does this have, or how much power this is the capacity it has to store, because that's going to tell you how long you can run devices and appliances at your house. But let me back up just a little bit more. You got to look out for the scenario that you're going to need it also. Are you looking for a solar generator that's going to power your home? Are you looking for a solar generator that's going to power your RV or trailer? Are you looking for a solar panel to go camping? or one that you just want everyday carry and throw it in your backpack as you're going to school or work or wherever you're going. That actually determines probably the watt hours you're going to look for in a solar generator. If you're looking for something small and portable, throw in your backpack, you probably want something less than 100 watt hours of power. For quick emergencies and camping, and even with a small trailer or something like that, you're probably looking at anywhere from like 1,000 watt hours down to 500 watt hours. If you're looking at something for your home that can power more power intensive appliances like a microwave or dishwasher or a window air conditioning unit, you're going to probably want something 2,000 plus in watt hours. So first, identify how you want to use it and what do you want to use it for. And then that's the watt hours. Second, you want to look at the wattage, which is basically how much power can I get out of the unit at that time. And for instance, a microwave requires about 1,500 watts. Our Grid Doctor 300 will not power that. You will need to up it to the Grid Doctor 3300. And the 3300 could handle 2 microwaves at the same time. Plus, have an extra 300 watts of power to go to powering devices.
What about like a full-size oven or range top?
I'm not sure the power consumption on those. I'm probably sure it's similar into the 1,500 to 2,000 range. The Grid Doctor 3300 would easily power a range, electric stove, for instance. So first off, look at watt hours, the size of battery. The second is look at your wattage. And this all depends on the use case you're going to use it for. Are you going to use it for camping, for home backup, take it to school, whatever? That's kind of the scenario, what you want to look for first. And then you want to start looking at the ports on it. Does it have AC? Does it have an RV port? Does it have USB? And what type of USB? Does it have your power delivery USB ports, which deliver more power, or just normal USB-C or USB-A? You kind of have to know what you want to power up and find the ports and connections that you have. And then you can get deeper in and start comparing stuff like, well, how fast will the solar generator charge up? Because that's important, because maybe you only have a couple hours that you have to set up a solar panel and charge it, or your battery drains and you need more power to take out to your job site. You've got an AC port. So, man, I don't want to be not working on my log cabin that I'm building in the woods for too long. So you go home, you charge it for an hour and a half and run back out and start building. So time is very important. How quickly you can charge your solar generator back up is another big thing. And I'm trying to think what else is another thing. Ease of use. Does the display make sense to you? Do you understand what the numbers mean? Do you know how full your battery is? Just simple stuff like that. And with our larger unit, the fact that it's modular and it's expandable is huge. So you can get a lot of power and you can build it up over time. You don't have to buy the full 8 units of battery. You can buy the main unit and then add one once in a while to build up your supply of batteries, and it just expands your capacity to provide power. So modularity is important. Those are all important to look for.
Super awesome. Rick, just a couple of questions to wrap this up. Why choose a solar generator over a gas generator?
Probably the number one reason is silence. They operate very quietly. You can operate these safely indoors, and there's no fuel. You don't have to buy extra fuel for it. The sun is free. So this is basically safe, quiet, reliable power all the time.
That's a beautiful answer. So as far as solar panels go, is it worth adding more?
Are they worth adding?
Yeah. Is it worth adding solar panels? Like, are you is it worth like expanding it, like buying more than one panel?
Oh, definitely.
Or even using them at all?
Yeah. With solar panels, the Grid Doctor setup basically recharges itself. As long as the sun is shining, you've got reliable power when you need it.
So why is Grid Doctor better than like the cheap ones that you would buy off of Amazon?
The Grid Doctor incorporates a lot of safety into their products. They're just designed and engineered and built for durability. The quality is way better than anything you're going to find on a lot of these cheap Amazon products that are almost like toys. So basically, it's just they're built for durability, they're built for reliability, and they're just a great product.
So, Rick, just to kind of close up shop now, what is like the one thing that people should take away from this entire podcast?
Power is essential. Everything we do in our daily lives. Like, we don't even understand how important having a power source is. At a previous company I worked for, where I was developing a lot of these power battery packs and solar panels and stuff, we would do humanitarian missions to Africa. And just the fact of bringing power and electricity to a village that didn't have it before was astronomical. You don't understand how important it is just to be able to have a light on in your home. It allows you to do schoolwork when it gets dark. It allows businesses to stay open. So having power is extremely important. We're used to it here in the States. In a lot of countries, they don't have a reliable power grid, and having power is very important. Having backup is a necessity these days. You never know when the power is going to be out. A lot of people right now are using medical devices at night, like a CPAP or an oxygen pump or something like that. And they need constant power. They need to have these power just in case the grid goes down, and having backup is super important. So a takeaway, you got to always have plan B. Have a backup for your power, because you never know when it's going to go out. During hurricanes, we got some hurricanes going on the East Coast. Super important to have power.
Agreed. Awesome. Final thoughts. Where do you suggest folks can go more to learn more about all of this setup?
Okay, hey, you can go to griddoctor.com, or you can go to our My Patriot Supply, learn more about the Grid Doctor line that we sell. And I advise you, go check out the competition. We rock. We're up there. We've got great components, reliable equipment, and it's just a really good product line we've developed.
Definitely have put your heart and soul into it.
Yeah.
So we appreciate you. And thank you so much for coming, being a part of our podcast. Appreciate you, brother.
Okay, thank you.